Hi, good day everyone. Now I'm Pon Komati Virsingan, so meet you back in the lesson 3. So today I'm going to do with you a quick revision and I'm going to share a certain techniques for you to embrace in answering chemistry SPM for 511. Cool. Now, today I'm going to do with you on rate of reactions. So before we further up our lesson today, let me explain to you. So when we are talking about rate of reaction, so what are the important parts you have to be well versed when you want to answer the question regarding rate of reactions. Firstly, you must know how to define rate of reaction correctly. Second, students must know how to go on the calculation for average rate of reaction and instantaneous rate of reactions. These two calculation on rate of reactions, you have to apply a different method, okay? And then you also must know what are the factors affecting the rate of reaction and their respective experiments involved. And based on the parameter given for the experiment, you should be able to compare and contrast between the rate of reaction between the two experiments given to you. And upon comparing the rate of reaction, you also should be able to sketch the graph in the same space. And students must know how to apply collision theory to explain on the respective factors which are affecting the rate of reaction according to the reaction given. And beside whatever factors you have learned, you also should be able to apply the factors in determining on the application part, how these factors are affecting our daily life, how we use these factors in our daily life, the application part for the rate of reaction. And there's one more part which is interrelated to your Form 4 Chapter 3 calculation, where students must know how to calculate the volume of gas released in the reactions. So these are the parts we're going to focus today. Okay, come let's do a quick revision on the definition of rate of reactions. Okay, what is meant by rate of reactions? So as we know, in any chemical reactions, we need reactants to react, and when they react, they will form the respective products. So we can observe the changes that occurs in the reaction based on the amount of reactant or based on the amount of product. So in any chemical reactions, the reactant will react. So when the reactant react, what the changes that you will observe is the decrease in the amount of reactants. So regardless of whatever type of reactions is that, always the changes that you will observe in the reactants is the amount will decrease, and in return the amount of product will increase. Okay, this is a common changes that occurs in any chemical reactions. So how we define rate of reaction is we are measuring on the changes in the amount of reactant or product based on time taken. Okay, so when the question comes out to define rate of reaction for the respective reaction given to you, you have to be careful about what are you measuring in the reactions. And is it a reactant or the product? If you are measuring about reactant, then you have to say decrease in the amount of reactant. And the amount of reactant you must have a measurable parameter for it, like mass. For example, let's say we are taking this reaction shown here. Zinc carbonate react with hydrochloric acid, hence it forms zinc chloride, carbon dioxide and water. So if I want to measure the rate of reaction for this reaction based on reactant, so what's the parameter I can use for zinc carbonate is mass. Okay, mass of zinc carbonate, or I can use on concentration of hydrochloric acid. So both of these parameters, they will decrease, the amount of reactant will decreases. Whereas for product, how we can measure the product? So here you can see the product form is zinc chloride, carbon dioxide and water. So we can measure zinc chloride based on the mass, and whereas for carbon dioxide we can measure in terms of volume of gas. So let's say they have given you this type of reaction in your question and they ask you to define the rate of reaction. So let's say I'm going to measure this reaction based on volume of carbon dioxide. So when I want to define, I have to say that increase in the volume of gas release per unit time. Okay, students, when you want to define, you have to put it in terms of per unit time, not per time. Most of the time, students, the candidates, what they use is per time. That's wrong. Per unit time. Okay. So that's the correct way how you define rate of reactions. Okay, just now we saw on the definition for rate of reaction. Now we're going to look at the calculation involved for rate of reaction. As you all aware, there are two types of calculation involved for rate of reaction. One is average rate of reaction. Another one is called instantaneous rate of reaction. And both of these calculation, the methods are different. Don't get confused. Okay, now let's look at average rate of reaction first. When we talk about average rate of reaction, it actually is measured based on the change in the selected quantity per unit time taken. For example, as you can see here, average rate of reaction in the first 50 seconds. Okay, when they say in the first 50 seconds, that means the time taken will be from 0 second up to the 50 second. So the difference in the volume of gas collected from the 0 second to the 50 second will be divided with the time taken. So let's say now we are getting the data from the graph. So this is the curve had been given to you. So what you have to do, you go to your 50 seconds, look at the highest volume collected, which is 30. Initial was 0, right? So the difference in the volume of gas collected, 30 minus 0, so you get 30, divided with the time taken, 50 minus 0 as well, so you get 50 seconds. So press your calculator now, 30 cm cube divide with 50 seconds. Hence, you will get your answer 0.6. And very important in calculation of rate of reaction, make sure the unit you stated correctly. You follow your unit given in your data. If they have given you in cm cube, then volume must be in cm cube. If the time is given in second, then it must be per second. If it's in minute, then it will be, your calculation will be represented in the unit of per minute. And then average rate of reaction between 50 and 90 seconds. Okay, here they have given you a timeline for you to calculate the average rate of reaction, which is 50 to 90. So what you have to do is, the timeline is 50 to 90, right? Go and see the highest volume collected for 90 seconds, which is 40 cm cube. Whereas for 50 second, the volume of gas collected is 30 cm cube. So what's the difference in the volume of gas collected? 40 minus the 30, divide with the timeline. The timeline is 90 minus the 50. So when you press your calculator, so you'll get 0.25 cm cube per second. The very important part here, when you're calculating your average rate of reaction, make sure the period of time taken and the data you are taking in your calculation is very important. Make sure you take the correct data. Okay, now there's another way of calculation where they mention about, okay, what's the average rate of reaction in overall. So when they are mentioning about overall or the whole reaction, then how do we go about the calculation is, first thing, students, you have to go and determine what's the time taken for the reaction to complete. If they have given you a curve like this, so go and look at the curve at the point where it becomes constant. So as you can see here, this is the point that initially becoming constant, right? So at that point, the time taken is 90. So that shows that 90 seconds is the time required for the reaction to complete. So at that point, go and see and find the volume of gas collected. That consider the highest volume of gas collected. So you take the highest volume of gas collected, divide with the time taken for the reaction to complete, if you want to calculate on average rate of reaction for the overall. And then you press your calculator so that you get 0.44 cm cube per second. Now, what I show you here is based on graph. Now, there are times for average rate of reaction, you don't need to plot the graph. be able to do the calculation with tables, the data represented in the table. So how to go about it? In a while I'll show you a few examples of questions, and I will teach you how to do the calculations as well. Okay, so now I hope you are clear about the average rate of reaction. So now we're going to look at instantaneous rate of reaction. When we are mentioning on instantaneous rate of reaction, what is that actually? Instantaneous rate of reaction, impossible you can do it with your data table. Okay, you must draw graph. Why? Because instantaneous rate of reaction is actually the gradient of the graph at any given time. So due to that, for instantaneous rate of reaction, students are always required to draw the graph based on the data given to you. Then after you draw the graph, you go and draw tangent at the particular plot required. For example, let's say they ask you to calculate the rate of reaction at 50 seconds. Now, how do you differ whether it's the average rate of reaction or instantaneous? By reading it, you should know already. Always the instantaneous, they just mention it as rate of reaction at. You don't see the word average. If it's the average rate of reaction, they will mention it average. Okay, so this is one of the obvious difference, can be a hint for you to determine which method to be used for your calculation. Okay, so now if they have given you instantaneous, so for example, now they ask you to calculate the rate of reaction at 50 seconds. So students, what you have to do is, upon drawing the graph, bring your ruler closely to the plot at 50 seconds and draw a tangent. Okay, after you draw a tangent, choose a right angle triangle and then you calculate the gradient of that tangent by using y2 minus y1 over x2 minus x1. So you find the difference in the volume, divide with the difference in the time taken. And that is what we consider as instantaneous rate of reaction. Okay, so just now we looked at the method used for the calculation for average rate of reaction and instantaneous rate of reaction. Now let's try on the example of questions for the calculations. Now, as you can see here, question 1, table 4 shows the total volume of oxygen gas collected in the decomposition reaction of hydrogen peroxide, and data table is represented to you. Now, what is the overall average rate of reaction? So, what's the keyword? Students, when you read your questions, kindly please highlight the keyword, overall average rate of reactions. So, when the moment you see the word average, then you should know already, you no need to draw the graph. With the data table, you're able to proceed with the calculation for average rate of reactions. And another keyword here, you have to be careful. They are requesting for overall average rate of reaction. So you remember as what I told you just now, for overall average rate of reaction, the first thing you have to determine the time taken for the reaction to complete. So how you go about it? Please look at this table. Look at the volume of gas collected. What is the highest volume of gas collected? Which is 50. And you will see the reading is repeated constantly. Repeated, right? Now, when it's constantly repeated, that shows that they already reached to the max. This is the maximum volume of gas collected. So, look at the data table and take the first reading of 50. Now, determine the time taken where you obtain the first reading of 50 cm3. So, based on data table, 180 seconds is the time required for you to collect the 50 cm3. That means the time taken for the reaction to complete is 180 seconds. So now in our calculation, the very important data is this. So when you are calculating on overall average rate of reaction, we already know the highest volume of gas collected was 50 cm3. Okay, where minus with the initial, which is 0 cm3, right? And the time taken for the reaction to complete is 180 seconds, 0 second. So kindly press your calculator. 50 cm3, you divide it with 180 seconds. So what's the answer? Are you getting it now? Yes, you'll be getting C, 0.2. 0.278 cm cube per second. So now this is a paper 1 question. The same question can be questionable for your paper 2. So when you are doing the same question in your paper 2, kindly show your workings and make sure the unit you are stating it correct based on the data represented. Okay, let's try on the second question now. They have given you the data in the form of graph. So the question here, find out the keyword. What is the average rate of reactions? So now they didn't mention it whether it's overall or what, but they just say what's the average rate of reaction. When they ask for average rate of reaction, that means they are focusing to the overall. So now what you have to do is same thing, go and look at your graph. Find the highest volume of gas released. Can you see the constant line? The highest volume was 50, the first point over here. So kindly bring it down and record the time taken. So the time taken for the reaction to complete will be 20 seconds. So what you have to do is you take the highest volume, 50 cm cube. You divide it with the time taken, which is 20 seconds. So kindly press your calculator and determine the answer. Yeah, you'll be getting about 2.5 cm cube per second. Now let's look at question number 3. Question number 3 is actually is not that difficult, but is a kind of trick had been used. This is a kind of K-part question as well. Now let's read it. 0.2 mole of zinc powder react with excess dilute hydrochloric acid. After 30 seconds, 0.05 mole of zinc remain as residue. What is the average rate of reaction? So remember what I told you just now. The rate of reaction not necessarily must be always volume, as long as you're able to measure the changes in the reactant and the product. So now we are measuring what? What is the data is given to you? They have mentioned to you about 0.2 mole of zinc powder is react with excess dilute hydrochloric acid, and they also have said after 30 seconds 0.05 mole of zinc remain as residue. That means it's unreacted. So how many mole of zinc had been reacted? So what you have to do is you initially use 2 mole, but at the end of the day there was a remainder of 0.05 mole which is unreacted. So please calculate the number of mole of zinc reacted with excess dilute hydrochloric acid. So 2 you minus with 0.05 mole. So how much do you get? The number of moles reacted will be 1.95 mole, right? And they have already said after 30 seconds, that's the timeline for the reaction that had been occurred. So 1.95 mole, you divide it with 30 seconds. So what's the answer you obtain? Yes, you'll be getting the answer is C. Okay. Okay, now this is an example of paper 2 structure questions on the calculation part. Okay, so now let's look at the data given to you. Set 1, they have given the materials and they have stated volume of gas collected in 2 minutes for set 1, which is 30 cm cube. And in set 2, the volume of gas collected in 2 minutes will be 50 cm cube. So you are required to calculate the average rate of reactions. So when come to this type of question, students, get yourself very clear. We are going to calculate on the average rate of reactions. So as I told you, if there's no timeline given, that means we are focusing on the overall. So for overall, you just have to know on the volume of gas released and the timeline, which is 2 minutes. So for set 1, what you have to do is go and take the volume of gas released, which is 30 cm cube. You divide it with the timeline, which is 2 minutes. 30 you divide 2, so you get 15. And if you just leave your answer like this, no marks will be given to you, because in chemistry, just a number doesn't bring any meaning. You must have a unit for it to derive the meaning for it. Okay, so right now the unit for this will be cm cube per minute. Make sure you write the correct unit, then you will be rewarded with the marks. But as for set 2, 50 cm cube divided with 2 minutes, so it's going to be 25 cm cube per minute. Now sometimes students ask me, teacher, is that I need to convert the minute to second? No need. You follow your calculation based on the data given to you. So don't crack your head of converting it to second and so on. You're taking a risk. If you wrongly do the conversion, then it will affect your marks. So try to do it simple and straightforward to the answer. And then comparing the rate of reaction between set 1 and set 2. How do I determine which one is higher? You look at the number. The bigger the number, the greater the number, that means that's the indication the rate of reaction is higher. So when you're comparing set 1 to set 2, we understood that set 2 rate of reaction is higher. So you just say set 2 rate of reaction is higher than set 1. Okay students, we have finished on the first part of rate of reaction involving the calculations. So now we're going to move on to the second part for the chapter. That's about the factors affecting the rate of reaction. So before we look at the questions, let's do a quick revision on the factors affecting the rate of reaction. Okay, here is the summary on the factors affecting the rate of reaction. Altogether, there are actually 5 factors affecting the rate of reaction. Now let's look at the first one, the size. So students, you must have a very good understanding on the concept of factors. Okay, how the factors affecting the rate of reaction. So now let's look at the size. When the size is smaller, total surface area is larger. When the total surface area is larger, the rate of reaction will be higher. It will increase. Secondly, concentration. When the concentration increases, rate of reaction must increase. Okay, besides knowing the concept, you also must know the correct relationship on the factors influencing the rate of reaction. Thirdly is temperature. When temperature increases, rate of reaction increase. Okay, regarding the catalyst, what you have to know is catalysts have 2 effects on the rate of reaction. One is absence or presence. Whenever there is a presence of catalyst, rate of reaction will be higher compared to the absent one. And the other effect is based on the quantity. As the quantity of catalyst increases, then the rate of reaction will also increases. And finally is about pressure. When the pressure increases, rate of reaction will increase. Okay. Besides knowing each factors and how they affect the rate of reactions, students, you also must be able to interpret the graph given to you. You must understand based on the steepness of the gradient, the curve, you should know whether which point having the higher rate of reaction. Now let's look at this first graph here. They have plotted a tangent. They have drawn the tangent at T1 and T2. So what you have to know is actually the steepness of the curve is actually representing the rate of reaction. Based on the steepness of the tangent, we can determine whether the gradient is greater or lower. So as you can see for T1 and T2, the steeper it is, the gradient will be greater. So when the gradient is greater, the rate of reaction is higher. So the rate of reaction at T1 is higher than T2 because you can see the gradient of T1 is steeper compared to T2. Now let's look at this graph now. They have plotted the 2 curves in the same space. So now what you can see it, they are having 2 different curves. One is steeper than the other. So when the gradient in reaction 1 is steeper than in reaction 2. This is more steep compared to reaction 2. So that shows that the rate of reaction for 1 is higher than the rate of reaction of 2. So this is the important understanding the student should have on the factors affecting the rate of reaction, and they also must be able to interpret the graph given correctly. Okay, we're going to look in detail about each factors and how they are affecting the rate of reaction and the experiment regarding it. Okay, now let's look at the effect of size. Now, when we are talking about the effect of size, the very famous setup and very frequently will be questioned in your paper 2 is drawing the setup. Okay, students, please train yourself to draw this setup always. And the very common errors of the candidates when they're drawing the setup is they forgot to place the stopper. Always remember, when you place your stopper, must show half in and half out. That's very important. Okay, and then make sure your delivery tube is at the mouth of the inserted to the mouth of the burette. Then only is considered functional, and it shows the clamping part. Okay, so please label all the materials involved in the apparatus setup. So for this type of question, they'll give you about 2 marks. So it's actually quite easy for you to get the 2 marks. Don't miss out the 2 marks. Okay, next, students, you should know how the size affecting the rate of reaction. For example, right now they have given experiment 20 cm³ of 0.5 molar hydrochloric acid and excess calcium carbonate small chips, whereas for experiment 2 they use the same volume and molarity of the acid with excess calcium carbonate large chips. So what we can see here, the size of calcium carbonate differs, which is going to affect the rate of reactions. Now, apart you are comparing the rate of reaction, students, you must know how to write the balanced chemical equation for this reaction. The balanced chemical equation is quite famous, and upon writing your balanced chemical equation, you are also required to write the ionic equation. Please get yourself clear on how to write the balanced chemical equation and ionic equation. This ionic equation is very important because based on this we are able to determine the particles involved in the collision based on collision theory. So that's why I say that always emphasize on ionic equation. So right now, as you can see here, calcium carbonate react with hydrochloric acid, right? Calcium carbonate is a solid, so is no free moving ions. You can't split the ions. So you have to write for ionic equation as it is. Don't do any splitting. And when it comes to acid, it contains free moving ions, and the very important ions involved in the reaction is hydrogen ions. And then put up the arrow. So among the product form, remember whatever you have before the arrow have to be stated after the arrow when you are writing your ionic equation. So one of the product formed is calcium chloride. Calcium chloride are soluble salt, contains free moving ions. There are 2 ions, calcium ion and chloride ions, but counter check with the front one. Do you have chloride? No, right? So we only take calcium ion. So calcium you have to write in the form of ions, Ca2+. And water molecule and carbon dioxide, anything exists in the form of atom and molecule, we don't disturb them, we just write them as it is. Okay, so remember this is the ionic equation for the reactions between calcium carbonate and hydrochloric acid. Okay, so now based on this data given, I mean the information given, experiment 1 using small, experiment 2 using large. So students, you already have the concept of size, how the size affecting the rate of reaction, right? So you must be able to relay your concept here. The smaller the size, higher the rate of reaction. So from here what we can write is the rate of reaction of experiment, which one is higher? 1 is higher than 2, isn't it? And remember, decimal rate of reaction in the curve is represented by the steepness of the curve. So when you draw the curve for experiment 1 and 2, the curve for the experiment 1 should be steeper than for experiment 2. And then as you can see in your graph, okay, later I'll show you and I'll explain to you how to go on sketching the graph. But now generally you must understand about your graph. Based on this experiment 1 uses small, so that experiment 1 should have the higher rate of reaction compared to experiment 2. So the curve of 1 should be steeper than 2. Okay. Okay, now this is the temperature and concentration factors. For concentration and temperature, we are using a common reaction, that is sodium disulfide solution will be reacted with acid, and it will form the sulfur dioxide and water, which will result in the disappearance of X mark from the view. The rate of reaction for both these factors are measured based on the time taken for the X mark to disappear from view. Okay, now when we are talking about concentration and temperature, because we are using the same reactors, but the procedure involved for the experiments are different. So please kindly go and do your revisions on the experiment part, how we carry out the experiment for concentration, how we carry out the experiment on temperature. This is quite famous and might come out for your essay, design and experiments. So get yourself very clear about the procedures. And the second part you have to focus is on the graph part. Okay, for concentration and even temperature, there are two types of graph involved. One is the concentration against time, another one is concentration against 1 over time. So remember students, 1 over time is actually indicating to the rate of reactions. So from this graph, what you can conclude here is, as the concentration increases and the concentration is higher, time taken for the X mark to disappear is shorter. But when the concentration decreases, time taken for the X mark to disappear becomes longer. Okay. Now, when we are plotting the relationship between concentration to the rate of reaction in terms of 1 over time, is actually directly proportional. But in chemistry, we don't mention it directly proportional. It's advisable for you to say, as the concentration of the sodium disulfide solution increases, the rate of reaction increases. Same goes to temperature. When higher the temperature, time taken for the X mark to disappear from view will be shorter. As the temperature decreases, the time taken will become longer. So that's why you get this type of curve. Okay. But the same thing, we can plot it in terms of temperature against 1 over time, which is rate of reaction. So the relationship is, as the temperature increases, rate of reaction increases. Okay, now this is regarding catalyst. When we talk about catalyst, the very famous reaction involved is decomposition of hydrogen peroxide. Quite famous, so students, make sure you know the balanced chemical equation. And for your kind information also, the balanced chemical equation and the ionic equation for the reactions are the same, because all are involved are molecules. So it's the same one. Now, as I mentioned to you earlier, when we talk about catalyst, there are two effects. One is based on the presence of catalyst, another one based on amount of catalyst. So what we can conclude here, when there's a presence of catalyst comparable to the absent one, the present catalyst will have the higher rate of reaction. When come in terms of amount, as the amount increases, rate of reaction also will increase. And students, you must know how to carry out the experiment to study the effect of catalyst on the rate of reaction. Please kindly look at the procedure as well. And other than that, please get yourself very clear on the usage of catalyst, because catalyst usage are very specific for the reactions. We can't use simply all catalysts for all reactions and so on. Okay, and we are mentioning about decomposition of hydrogen peroxide. So the catalyst used will be manganese peroxide. Okay, if the reaction using zinc and acid, so the catalyst will be copper 2 sulfate. So these are the names of the catalyst you have to use. And you also must know about the properties of catalyst. Catalyst is only used in a small amount. As I mentioned to you, it's a very specific action. And catalyst is actually not directly involved in the reaction, it's only speed up the reactions. Okay, so now let's go for the Q&A session. Question number 1. What is represented by the gradient tangent x? Okay, class, just now only I told you, right? Gradient tangent is actually representing the rate of reactions. And as you can see here in the curve, they draw the tangent. So when there is a tangent, it must be an instantaneous rate of reaction. So as you can read it, so the best answer will be rate of reaction at second minute. So now let's look at question number 2. When the temperature of the reacting mixture increases, the rate of reaction increases. So which one explains why the rate of reaction increases? Now, every factors have their intermediate points to explain about. For example, when we are talking about size, it must relate to total surface area. When you are talking about concentration, it must relate to the number of particles per unit volume. And same goes for temperature. Temperature, the keyword you have to relate to is when the temperature increases, they gain more kinetic energy and they collide more frequently and they able to overcome the lower activation energy. Okay, so now as you can see here, which statement describe the best? Okay, A will be rejected because total surface area have nothing to do with temperature, it's about size. Total number of reacting particle per unit volume, that's about the factor of concentration. Now, let's look at C. The reactant particles move faster and collide more often with one another. Whereas for D, the reacting particles which collide more often are able to overcome the lower activation energy. So which one is the best explaining about the factor of temperature affecting the rate of reaction? So the best explanation will be D. Remember, our concern of temperature is when the temperature increase, of course they gain more kinetic energy. When they gain more kinetic energy, they collide more frequently. When they collide more frequently, they are able to overcome the activation energy. Okay, that is what caused the rate of reaction to increase. Next, for question number 3, zinc react with hydrochloric acid. Now, how can the rate of production of hydrogen be increased? So, they are talking about how can we increase the rate of reactions. So, look at the nature of hydrogen gas, right? So, look at each nature of the reactant and the products. So, if you want to increase the product, the yield, we have to manipulate the factors for the reactants. For zinc, they say increase the size. Do you think increasing the size will increase the rate of reaction? The correct concept is we have to decrease the size, not increase the size. Okay, if we want to increase the rate of reaction. So A is not acceptable. Increase the volume of water in the acid. Do you think volume of water being a factor? No, right? But even when you increase the volume of water, what will happen to the acid? It will affect the concentration. Concentration will decrease. So, wrong concept too. Now, increase the volume of hydrochloric acid. Increasing the volume wasn't being a factor. So, if that's nothing to do with your rate of reaction. Increase the temperature of hydrochloric acid. Yes, temperature is the factor. So, when you increase the temperature, the rate of reaction can increase. So the best answer will be D. Okay, now we are going to move on to the third part, which is talking about collision theory. Now, collision theory is quite famous and always is questionable whenever there's a question on rate of reaction come out. It's quite famous for your paper 2. Widely can be questionable in your structure or even for your essay. So students, you have to be very clear about the collision theory. Okay, first of all, you must understand what is collision theory. Collision theory means the collision must occur at the correct orientation and the colliding particles must achieve the lower activation energy, which will result in an effective collision. Then only it can result in the reactions. Now, when we are talking about collision theory, there are a few things you have to be emphasized here. First, when we are talking about size, students, as I told you earlier, the smaller the size, we will relate to the larger total surface area as opposed to collision. So when you write your essay later, make sure you emphasize on this. Okay, whenever you are talking based on collision theory, yeah, size smaller, larger the total surface area as opposed to collision. When we are talking about concentration, the higher the concentration, the higher is the number of particles per unit volume. Okay, the particles is a very general term. You will have to be mentioning specifically the name of the particles involved in the reactions based on the reaction given to you. And then higher the temperature, kinetic energy increases. If it's a catalyst, it will provide an alternative path with lower activation energy. So these are the intermediate points you have to talk about when you want to explain on collision theory. After you explain on the intermediate point, then the next you have to relate to the frequency of collision between the particles increases. Then the following will be frequency of effective collision between the particles increases, and finally it will result in the rate of reaction. Okay, in a while I will explain to you on how to write essay based on collision theory. So for now, make sure you have the bigger picture about how to go about writing collision theory, yeah, how you're able to connect the factors and collision theory. Okay, beside that, beside collision theory, students, you also must know how we apply the factors which you have learned in chemistry lesson in your daily activities. For example, cooking in pressure cooker. When you are cooking in a pressure cooker, comparable to normal wok, whatever food had been cooked in the pressure cooker will be cooked in a shorter period of time. Why? Because high pressure. The high pressure will increase the boiling point. When the boiling point increases, kinetic energy becomes higher. Kinetic energy of the particles in the food becomes higher. So, when the kinetic energy increases, time taken will be decreases for the food to be cooked. Next, storage of food in the refrigerator. Usually this type of question will come up for essay. They will ask you to explain why the food stored in the refrigerator lasts longer comparable to the one had been left in the kitchen cabinet and so on. So in that case, students, you have to determine the factor. So now in this scenario, the factor applies here is on temperature. So the food kept in the refrigerator because low temperature. When the temperature is low, what happens? It slows down the activity of the bacteria. Less toxin is produced. So rate of decomposition becomes lower. So these are the keywords you have to mention it in your answer for you to get marks for your essay write-up. Now, cooking of solid food in a small size. Any cooking when we do, we have to cut the food into smaller sizes so that you can cook faster. Why? When you cook in a smaller sizes, total surface area becomes larger. When the total surface area of the food becomes larger, they can easily absorb more heat. When more heat is absorbed, thus the food will be cooked in a shorter period of time. And in contrast to charcoal, okay, just now we talk about the food. So food will cook faster because they need to absorb heat. But let's say we talk about charcoal. Why you want to do a barbecue? We will use the smaller pieces of charcoal rather than the big pieces. So charcoal here is producing heat. So you have to relate to their functions. You cannot simply say a small size will absorb heat. No. Charcoal here is producing heat for the food to be cooked. So when we are using a smaller piece of charcoal, it will burn quickly and produce more heat. When it produces more heat, the food will be cooked in a shorter period of time. So these are the common type of application will be questionable in your paper too. Now we are moving to the next session. So now we're going to look at how to sketch graph. Now let's look at the question given. They have given you two experiments. Both are using 50 cm cube of 1 molar hydrochloric acid, but the difference you can find here, experiment 1 using chip, whereas experiment 2 using powder. So by reading this, students already have the knowledge about the factors applied for this reaction, which is on size. So first thing, what I will recommend you to do is identify the factor and compare the rate of reactions. So the factor you already determined, the difference is in terms of the size of zinc. So from that, draw the conclusion for the rate of reaction. So because experiment 2 use powder and you relate to your concept, the smaller the size, higher the rate of reaction. Hence, experiment 2 rate of reaction is higher than experiment 1. Okay, upon you draw this conclusion, what you have to do is step 2, you go and sketch the gradient of the curve and label it. As what you can see here. For this reaction, the reaction is measured based on volume of gas released over the time taken. So we know that experiment 2 should be higher rate of reaction, right? So we will have two curves. One curve is steeper than the other. The higher one will be steeper. So experiment 2 is higher, so that's going to be a steeper curve compared to experiment 1. And then determine the volume of gas based on the number of moles. Okay, look at the number of moles or the quantity of the reactant used. Both experiment use the same parameters. That means the number of moles are the same. When the number of moles are the same for both, that means volume of gas released is the same, is a common. It should be a common constant line for both. Okay, so second part, what you do is you can draw the constant line with the curve. And then fourth, you go and match. You already have the two curve steepness and one constant, you can match it. So at the end of the day, you're able to get the curve correctly. Okay, now let's look at this question now. Table 1 shows the condition. Okay, let's look at experiment 1. They use zinc granules and 50 cm cube 2 molar hydrochloric acid, whereas experiment 2, zinc powder. Okay, students, let's apply the steps I've taught you just now. First thing, go and determine the factor. The factor affecting the rate of reaction is size. And based on size, we know already rate of reaction experiment 2 is greater than experiment 1. So when it's like this, in your curve, you must have two steepness, right? This should be 2, this should be 1. So these are the sketch you have to do it first. And then look at the number of moles. The number of moles given are the same. So when the number of moles are the same, that means they are having only one constant level, common for both. So the best answer will be D. Okay, let's look at this now. Experiment 1, excess marble, 50 cm cube 2 molar hydrochloric acid, and experiment 2, excess marble with 50 cm cube of 1 molar hydrochloric acid. As you can read here, you can see the difference is 2 molar hydrochloric acid, 1 molar hydrochloric acid. That means the factors will be concentration. And based on the concept of concentration you have learned, higher the concentration, higher the rate of reaction. In that sense, we can draw the conclusion that the rate of reaction of experiment 1 is greater than experiment 2. So I told you already, when the rate of reaction is higher, that means they are not going to have a one common curve, they are going to have two different curves. So 1 should be steeper than 2. Then we go for the volume. Look at the number of moles. 50 times 2, we're going to get 0.01, whereas this is going to be 0.005. So the number of moles for experiment 1 and 2 is not the same. So please do your calculation. 50 times 2 divide 1000. You get 0.01. and here 50 times 1, say 1000. So you're getting 0.05. Please press your calculator. 50 divided by 1000, you get about 0.05 mole. I think here, press your calculator. Okay, you'll be getting about 0.01 mole. So that shows that the constant level for both are different. You will have two different constant level. Who is higher? Who is higher? You have to see based on the number of moles. Okay, as you can see here, the number of moles for both are not the same. So we are having two different lines, and one is higher than 2. So you please label it 1 and 2. Then you go and mesh them. So when you mesh them, you should be able to get the answer. The answer is A. That's the curve for this experiment. Okay, so now we are going to move on essay writing based on collision theory. Okay, I'm using the same reactions here. For you to write your essay based on collision theory, my advice is, firstly, please write your balanced chemical equation and ionic equation. So the purpose of you to write a balanced chemical equation and ionic equation so that you can see the reacting particles clearly. Easy for you to name it. Step 2, identify the rate of reactions and compare it. So here, as I taught you previously, they use zinc chip and zinc powder, so the factor is size. So based on size, experiment 2 will have a higher rate of reaction compared to experiment 1. So how we go on writing the essay? The first point, you have to mention about the factor. The factor here is the size, right? So size of zinc used in experiment 2 is smaller than experiment 1. Remember, when you're writing an essay, you have to compare. So you have to mention both experiments comparison. Then second point, please relate to the intermediate point regarding the size. When we are talking about size, we have to relate to this total surface area. So we have to mention about the total surface area of zinc exposed to collision in experiment 2 is larger than experiment 1. And thirdly, you talk about frequency of collision. When we are talking about frequency of collision, students, please be careful. We don't say frequency of collision between the particles. You have to mention the particles. For you to mention the particles, you're going to refer to the ionic equation. So what are the ions involved? Zinc atom and hydrogen ion. So that is what you will mention it in your frequency of collision. So frequency of collision between zinc atom and hydrogen ion in experiment 2 is higher than experiment 1. And then the following statement will be exactly the same, but what we will write is about frequency of effective collision. And finally, we'll draw the conclusion that the rate of reaction of experiment 2 is higher than experiment 1. This is how you have to write your essay for collision theory for the factor of size. Okay, now let's look at the second question now. They have given you experiment 1, experiment 2. Please find out what's the difference. What factor affecting the rate of reaction? So you can see the difference in 0.5 molar and 1 molar hydrochloric acid. So we can say that factor affecting the reaction is concentration of hydrochloric acid. Based on concentration, we can determine here that the rate of reaction of experiment 2 is higher than experiment 1. So when you want to sketch the graph, as I told you just now, we will have two gradient for the curve. Okay, and then please determine the volume of gas, the constant level. Will they have the common or they have a different one? So as you can see, the number of moles are not the same. So please do your calculation, MV over 1000, and we found that the volume of experiment 2 is higher than experiment 1. Then finally go and sketch your graph. So for this question, how we write the essay for collision theory. So for essay for the collision theory, as I mentioned to you, again please write the balance equation and ionic equation and identify the factors which we have learned. Concentration, right? So your point 1, you will say about the concentration of hydrochloric acid used in experiment 2 is higher than experiment 1. And then when we talk about concentration, students, you have to be very careful. The intermediate point for concentration is the number of particles per unit volume. So don't ever say particle, you have to mention. So right now the concentration is different in hydrochloric acid. So the very important particle in acid is hydrogen ion. So please mention the number of hydrogen ion per unit volume of hydrochloric acid in experiment 2 is higher than experiment 1. Then we go for frequency of collision. The frequency of collision between zinc atom and hydrogen ion in experiment 2 is higher than experiment 1. And finally, you're going to talk on frequency of effective collision. If you compare these two sentences, is about the same. The difference is you talk about frequency of collision, then you talk about frequency of effective collision. Finally, draw the conclusion that rate of reaction in experiment 2 is higher than experiment 1. Okay, let's look at next question now. They have given you experiment 1 and experiment 2, so please find out what factor affecting the rate of reaction. And before that, for collision theory, as I mentioned, write your balance equation and ionic equation so that you can see the reacting particles involved. So as you can compare experiment 1 and 2, we can see that presence of copper 2 sulfate, which is the catalyst. So the factor affecting will be presence of catalyst. So due to the presence of catalyst, we can draw the conclusion rate of reaction experiment 2 is higher than experiment 1. So how are we going to write the points for essay? First point, you have to talk about the name of the catalyst. Okay, this is a guidance for you to write your essay for catalyst, factor of catalyst based on collision theory. Yeah? So name the catalyst. So over here I'm using copper 2 sulfate. So you have to say that copper 2 sulfate in experiment 2 act as a catalyst. And what is the function of it? Provides an alternative path for the reaction to occur with the lower activation energy. Thus, more colliding, who is the colliding particles? More colliding zinc atom and hydrogen ion in experiment 2 able to achieve the lower activation energy than in experiment 1. So for your current information, when you are mentioning about catalyst, we straight away talk about frequency of effective collision because it's already achieved the lower activation energy. No longer we talk about frequency of collision. We straight away talk about frequency of effective collision between the zinc atom and hydrogen ion. Then finally, we draw the conclusion that rate of reaction in experiment 2 is higher than experiment 1. Okay, this is the final example. Again, for this example I'm giving you, the factors affecting will be temperature. Okay, so now I'm going to teach you how to write a collision theory essay for temperature. So now, as based on temperature, we know that experiment 2 have higher temperature. So which one do you think the temperature is applicable to? Zinc powder or solution? So solution, right? So we have to mention temperature of hydrochloric acid used in experiment 2 is higher than in experiment 1. And then we have to focus on the kinetic energy gained by the particles. So when hydrochloric acid gain more temperature, what happens? Zinc atom and hydrogen ion gains more kinetic energy and move faster. And they are able to achieve the activation energy. When they move faster, they will be more colliding. When they are more colliding, they are able to achieve the activation energy in experiment 2 than experiment 1. So as I told you just now, for temperature again, because it's already moving fast and colliding and achieving the lower activation energy, so we straightaway talk about frequency of effective collision. no longer talking about frequency of collision. Okay, and finally draw the conclusion on rate of reaction. So please be careful, students. Remember, out of 4 factors we have learned: size, concentration, temperature, and catalyst. For collision theory, when you want to write your essay, size and concentration, you will write about frequency of collision followed by frequency of effective collision, then only draw conclusion for rate of reaction. But when you're talking about temperature and catalyst, remember they are already achieving the low activation energy. Thus, we don't talk about frequency of collision. We talk about frequency of effective collision.